Okay, this video is on section 5.5, day 2 notes. So, yesterday we looked at double angle formulas. Today we're going to look at half angle formulas. And again, these are on your unit circle formula sheet on the back. So have those by you, next to you, while you are filling out your note sheet for today. So with these, what I want you to make note of is that there's going to be a plus or a minus in front when we are doing sine of x over 2 and cosine of x over 2. That means that you have to decide whether your final answer should be positive or negative. And that is all dependent on whether sine is positive or negative in that specific quadrant. So we will do examples where I'll help you decide which it should be. But know that in the end, it's one or the other, not both plus or minus. Tangent x over 2 has two formulas you can choose from, one or the other. I believe on the unit circle sheet there might be an equal sign here, and that used to confuse people. They used to think they had to do both formulas and kind of do like a ratio equals a ratio. I would prefer to take out that equal sign and write in the word or, so that you just know it can be one or the other. You don't have to do both. So we're going to practice using these formulas today. Okay, so our first example, we've got a picture of a triangle. I'm giving you the opposite side and the adjacent side. We could solve for the hypotenuse. You can do Pythagorean theorem, or you can realize that it is a common kind of right triangle, that the hypotenuse is going to be a 5. But I'll just do Pythagorean theorem. But yeah, 3, 4, 5 is a common right triangle. Okay, so we're going to use the formula for tangent of x divided by 2, or it could be theta divided by 2, it doesn't matter. And you can choose either formula. I just feel like choosing this version, the sine theta divided by 1 plus cosine theta. It does not matter which formula you use. On the top, sine theta, sine is opposite over hypotenuse, so that would be 3/5. On the bottom, we have 1 plus cosine theta, which would be adjacent over hypotenuse, 4/5. And that is something you could type straight in your calculator and get a simplified answer of 1/3. Remember the control divide in your calculator gives you that nice fraction like that. So I would use that a couple times when I type this in my calculator. Okay, next example. This should look similar to the problem we did in the notes when we were using our sum and difference formulas, where we would find two angles that add to 75 or two angles that subtract to 75. That's a good way of doing this problem, but I want to show you the same problem using half angle formulas. The half angle formulas, we have sine x over 2. We need x over 2 to be the same thing as 75. So we have to figure out what divided by 2 would equal 75. Okay, so 75 does not go here. It's something divided by 2 that equals 75. So the angle that goes here is 150. 150 divided by 2 is 75. The reason that we do this is because 150 is on the unit circle. 75 was not, but 150 is. Okay? When you go to use your formula, let me just kind of write the formula over here. It was plus or minus square root, and then we're supposed to do 1 minus cosine x over 2. So in this case, x is 150. So when we write our formula, plus or minus square root, 1 minus cosine, x is 150 degrees, not 75. Bottom line is, you would get stuck. If you accidentally put a 75 right there, you can't use your unit circle because 75 is not on the unit circle. X is what we divide by 2 to get 75. So x is 150, 150 goes there. So go to your unit circle and look up 150 degrees. What is the value of cosine? And the value of cosine is negative square root of 3 over 2. Remember, it's 1 minus that, so 1 minus negative square root of 3 over 2. And all of that is over 2. Okay, now I'm going to work with this stuff here. I cannot do anything until I have a common denominator. So I'm going to multiply this fraction by 2 on top and bottom. So I will have a 2, and then minus a negative turns into a plus, square root of 3, all over this common denominator of 2. This divided by 2 right here is right here. Okay, so it's a bit of a mess. We should probably multiply by the reciprocal. So I'm going to take all of that pink stuff, 2 plus square root of 3 over 2, and I'm going to multiply by the reciprocal of 2. Okay, then I need some more room, so I think I will continue up here, okay? I have 2 plus square root of 3 all over, so I'm multiplying across the tops and I'm multiplying across the bottoms, so I will have 4 on the bottom. Now remember, when you're taking a square root of a fraction, you can split it up. So I can do the square root of 2 plus square root of 3 on top, and I can do the square root of 4 on the bottom. Now the top is all jacked up, it's gross. But the bottom, square root of 4, turns out to be a nice 2. So apparently someone decided that the top can be terrible, but the bottom's got to look good. Now, the last thing I have to do is decide, should I have a plus or a minus? So what we need to do is look at this original problem, sine of 75. 75 degrees is in the first quadrant, and sine is positive in the first quadrant. So I'm only going to go with the positive answer. Okay, 75 degrees is in the first quadrant. Sine is positive in the first quadrant. So our answer is only going to be the positive version. Okay, that's how you tell whether it's positive or negative. All right, let's look at another example. Okay, 105 is not on the unit circle. So what we're going to do is we're going to figure out what the value of x would be. We're going to use a half angle formula. What divided by 2 is 105? So that would be 210. So the value of x is 210. Okay, so we're going to use our formula, plus or minus square root, and cosine x over 2 is 1 plus cosine x over 2. So in this case, it'll be 1 plus cosine of 210 all over 2. So go to 210 degrees. The value of cosine is negative square root of 3 over 2. All of that is over 2. Okay, so again, I need a common denominator here. So I'm going to multiply by 2 on top and bottom. So I will have 2 minus square root of 3 over my common denominator of 2. Again, that's all of this top stuff right here. But then I'm still dividing by 2. I'm going to continue it up here. So all of that pink stuff, 2 minus square root of 3 over 2, I'm going to multiply that by the reciprocal of my denominator. And now I'm going to multiply straight across the top, straight across the bottom. So on the bottom, 2 times 2, I'll have a 4. And again, I can split up so that I have a square root on the top and a square root on the bottom. The top looks terrible. The bottom, square root of 4, turns out to be a 2. So now I have to figure out, should my final answer be positive or negative? The original problem is cosine of 105. 105 degrees is in the second quadrant, and in the second quadrant, cosine is negative. So that means we want to only go with the negative version of our answer. Remember this little thing here? In the second quadrant, cosine is negative. Okay. Next example. Actually, we're going to skip that one because it's so similar. So we're going to move on to this one. Okay. We've got some hints here that we need to follow. We are told our angle should be between 0 and 2 pi. Not 2 pi, sorry, pi over 2. Between 0 and pi over 2. So that means that we are in the first quadrant. There's our angle u. We know cosine is adjacent over hypotenuse. So then we can do Pythagorean theorem. 7 squared plus b squared will equal 25 squared. So 49 plus b squared is going to equal 25 squared. What's that? 225? I'm 625, sorry. Okay, so 625 minus 49, we're going to get 576. Take the square root of that, and we should get 24. Since the side is pointing up, it should be positive 24. Okay, so we are going to find the exact value of tangent of u over 2. So we've got two different formulas we can choose from. It does not matter which one you choose. I just feel like doing the sine of u over 1 plus cosine of u. Sine of u, sine is opposite over hypotenuse, so that would be 24 over 25 over 1 plus cosine of u. Cosine is adjacent over hypotenuse, so that would be 7 over 25. And then you can just type that straight up in your calculator, and it'll reduce it for you, and you should get 3/4. With tangent, there's no plus or minus to worry about. Okay, one last example. This is a solving problem. I should write that in, that I want you to solve. Okay. So hopefully you look at this and you say, oh, I recognize that. That is a half angle formula, so I can replace it with one of the two versions. It does not matter which one you choose. I just, for the sake of it, I'm going to choose 1 minus cosine x over sine x. And then I have minus sine x here. And that is over 1 technically. And I can't do anything until I have a common denominator. So I'll multiply this by sine x on top and bottom. So my common denominator is sine x. On the top, I would have 1 minus cosine x minus sine squared x. And here's where you might want to be a little clever. The 1 and the minus sine squared x together would be a cosine squared x. And then I have this minus cosine x still. Okay. Let's see. We could factor out a cosine from both. So if I take out a cosine x, I would be left with a cosine x minus 1. Okay. Let's see. What we could do, since we're solving, is we could multiply the other side by sine x. Like if I multiply both sides by sine x, 0 times sine x would still be 0. So I would have cosine x times cosine x minus 1 equals 0, because 0 times sine x is 0. And then I can set each of these. Let's see, I'm going to see if I can scroll down a little bit so I have more room. Well, that doesn't help. Okay, I'll just squeeze it in. Set each factor equal to 0. And solve them separately. So here I would have to do the inverse cosine of 0. So where on your unit circle do you get a 0 for cosine? That happens at pi over 2 and at 3 pi over 2. And then over here I would add a 1, so I would get cosine x equals 1. And then I would have to do the inverse cosine of 1. Where do we get a 1 in the cosine spot? That happens at 0. So I have 3 solutions. Pi over 2, 3 pi over 2, and 0. Okay, so today is involving simplifying and solving and maybe even verifying using the half angle formulas. All right, have a good day. You can work on the homework now.